In a previous section, we looked at how to find the equation of a line in 3D. Assuming you have a line in R3, this is your x or z-axis, x-axis and y-axis, y, x, and z. Now let's assume you have a line in this space. This is the line. And the directional vector of the line, say you have a vector along the line or parallel to the line, it doesn't have to be along the line, and this vector is v, and assume that v is the vector a, b, c, and we also know that this line passes through a point. It could be any point on the line, and this point is point P, and let's call it x0, y0, z0. All right, then the equation of this line, we can write it as x is equal to x, y, z is equal to x naught, y naught, z naught plus t times a, b, c. This is one way of writing it, but we also said we can just split it up as x is equal to x naught plus at, y is equal to y naught plus bt, and z is equal to z naught plus ct, okay? Where t goes from negative infinity to infinity. Let's assume that this is an infinite line, not a line segment. Negative infinity to infinity, okay? And then another way that we looked at doing it was to write it as a vector valued function. This is already a vector valued function, but let's make it more formal by defining it as r of t is a vector valued function whose first value is x naught, first coordinate is x naught plus at, and then second one y naught plus bt, and then the third one z naught plus ct, okay? So we said that we call this a parametric equation. And then parametric equations and then we call this a vector valued. We look at this as vector valued function, okay? So vector valued function and parametric equation are related. Like, this is a perfect example of how they are related. So we're going to continue in this line of thinking. We already know about the equation of a line in R3, that it could be a parametric. We can express it as a parametric equation as a vector valued function. But we're going to go back a little bit, go back to R2 and look at how we can express curves in R2 as parametric equations or as vector valued functions also. So we're just gonna go into it with a bunch of examples. Okay. But before I go ahead, it's a parametric equation because t here is the parameter. The t, we have a parameter t over here. Okay. So, an example. Let's consider a parametric equation in R2. Parametric equation. X is equal to 2t, y is equal to 1/2 t squared minus 4. 0, t. T is between 0 and 8, and this is in R2. All right. So how about we graph the parametric equation? Graph and analyze the equation. Okay. So to graph the equation, let's make a table. I hate making tables because this iPad is very notorious for not allowing me draw a straight line. But you guys are gonna walk with me here. So this is t, this is x, and this is y, and then just assume there is then let's get a point xy. So assume there is a line here, and there is a line in between t, x, y, and xy. Okay. So our values are between 0 and 8. We're not going to do every value between 0 and 8. Let's pick 0. Then let's do 2. Or maybe let's do 1. How about that? 1 between 0 and 8. All right. Let's not do all the values. Maybe we should do 1 and do 2 and do... How about this? Let's jump. Let's do 2. Let's do 4. Let's do 6 and then 8. Well, I might even stop before 8, depending on how I feel. So x is 2t. When t is 0, x is 0. When t is 0, y is 1/2 t squared minus 4, so it's minus 4. So we have the point 0, -4. All right. Now let's look at t. T equals 2. When t is equal to 2, x is 4. When t is equal to 2, y is 1/2 times t squared minus 4. We get -2, I think. So we have 4, -2. Let's do a few more. When t is 4, x is 8. When t is 4, what is y? T squared is 16. Divided by 2 is 8. Minus 4 is 4. So we have 8, 4. All right. How about 6? When t is 6, y is x is 12, I think. 12, 2t. And then y is 36 divided by 2 is 18. 6 squared is 36 divided by 2 is 18 minus 4, 14. All right, so we have 12, 14, right? So let's stop there. Don't worry about this 8. We're going to see the pattern, and then we can do a few more things from there. All right. Okay, so let's now draw this graph. Again, I'm going to be working with a very limited set of apparatus here. Okay, so this is my y-axis. All right, and this is my x-axis. So I'm going to go all the way here for the y-axis, and then all the way there for the x-axis. All right, now this is x went all the way, y went all the way to 14. So I don't know if I can if I'm able to go all the way to 14 in this little space that I have. But let's see. So if we go divide them into little, this is 2, this is 4, and this is 6. This is 12. That's 12. Let's see if I can go to all the way to 14. 1, that's 2. That is, this is so uneven, but 2, that's 6. And then, oh, I can go all the way to 12. All right. 1, 2. Let's see. Oh, I can go to 14, but it's gonna be so uneven. I don't like it. I don't like it. I don't like it. Say what you want. I don't like it. But let's see. I want to go all the way to 14 though. Let's go. I know what I'm gonna do. Watch me do it. Watch me whip. All right. Oh no. What did I just do? I just did something weird. Okay. That's good enough. All right. All the way to 14. This is 2. This is 4. This is 6. 6. That is 8. That is 10. It's still weird. That's 12. That's 14. Good enough for me. All right. So when t is 0, when t is 0, x is negative, y is negative 4. So let's also do negative 4, negative 2, negative 4. All right. When t is 0, x is 0, y is negative 4. All right. So this is 0, negative 4. I'm not going to write all the points, but you see where I'm going with this. When, by the way, this is the x-axis and that is the y-axis. When t is 2, x is 4, and y is negative 2. So this is 4 and negative 2. And then when t is 8, when t is 4, x is 8 and y is 4. 8 and 4. That is 8 and 4. So this is 4 and negative 2. And this is 8 and 4. All right. When t is 6, x is 12. This is 12, and y is all the way at 14. So where is 14? This is 2, 4, 6, 8, 8, 10, 12, 14. So we have to go all the way there. Yeah, so this is 12, 14. All right. So now let's see what is going on. This is our curve. Our curve is moving in this direction. Watch the direction in which it's moving. This direction, the arrow. Yeah, we did it. We did it. We did it, did it, did it. So that is our parametric curve. So this is called the forward direction. This direction that it's going, it's called oh no, what did I do? I'm gonna make it yellow. So this direction is the forward. We call this the forward direction. We also call it the positive direction. Okay. Now, so this is our graph of the parametric equation. So that's how you graph a parametric equation in R2, R3, it doesn't matter. you just pick values for t and then find the corresponding values of x and y, or x, y, and z, and then plot them. So this is where, if you want to be more detailed, this is where t is 0. This is where t is 2. That is where t is 4, etc. All right. Now, what else can we do? We can ask another question. Can we eliminate the parameter to obtain an equation in terms of x and y, And my answer is yes. So let's can we eliminate the parameter t? Our parameter is t. So remember, we have x is equal to 2t. Oh, shoot. Begin with this. Copy this. Paste it down here, because we can. All right. So if you begin with t being, this is what we have. This is our parameter, our equation. I'm going to put it here. Make a circle around it. So you want to begin by solving for t in any of them. The easiest to solve for t is the first equation, x is equal to 2t, which tells us that t is equal to x over 2. If that's the case, that means that if we plug this t into y, we get y is equal to 1/2 x over 2 squared minus 4, right? So this implies that y is equal to 1/4 times x over 4. This is x squared over 4, sorry. So this is going to be x squared over 8 minus 4, okay? So this is our equation. We've managed to eliminate the parameter t. So that's our answer right there for this problem. Now, what is this? This looks like a parabola. I have to remember that I'm speaking English, not Latin. All right, so this is parabola, and if you look at our graph, you will see a perfect parabola actually. Because if you keep going, let's say you make t negative, you find the negative negative values for t. It's quite possible that this could go like this if you look for negative values of t and so forth. So that shows you that we have a parabola going on for us there. All right. Okay. Let's look at another equation. Example 2. We have x is cosine of pi t, and y is, x is 2 cosine pi t and y is 2 sine pi t. So we've talked about cosine and sine being assigned to x and y respectively, and we always end up getting something that's circular. So whenever we see cosine and sine together, we should be thinking of a circle, but it depends on the range of the parameter. Okay, the range might give us a semicircle, a quarter circle, and so forth. So let's try to graph and analyze this. Graph and analyze. All right. Again, let's pick values t, x, y, x, y. All right. When t is 0, let's go from 0. We're going from 0 to 1. So I'm going to do 0. I'm going to do 1/4. I'm going to do 1/2. And then I'm going to do 3/4 just for the heck of it. And then I'm going to do 1. Okay, you guys with me? So when x is 0, when t is 0, 2 cosine pi t is 2 cosine 0. So we just get 2. No. For x, we get 2. For y, we get 0. All right. When it's 1/4, we get 2 cosine pi over 4. Cosine pi over 4 is root 2 over 2. But then we're multiplying it by 2, so we just get root 2. So we get root 2 here. Same thing as sine, we get root 2. For 1/2, we're going to get 0 and 2. I want you to check it. For 3/4, we're going to get negative root 2 and root 2 here. And then for 1, we're going to get negative 2 and 0. All right. Plug in t equals 1. You get 2 cosine pi. Cosine of pi is negative 1. Multiply by 2, you get negative 2. Sine of pi is 0. Multiply by 2, you get 0. So our xy's is 2, 0, root 2, 0, 2, negative root 2. Oh, negative 2. No. Negative root 2, 2, right? Negative root 2. And then root 2. And then we have negative 2, 0. Okay. Now comes the moment of truth. Sketching it. At least for me. Moment of truth for me. Because I have to struggle and fight with my iPad, which always ends up cooperating. So let me not complain too much. So let's have our y-axis and then x-axis. Okay, so let's start when t is 0. When t is 0, so first of all, let's choose values. Let's mark our thing. This is 1. This is 2. Negative 1. Negative 2. 1, 2. And then let's now go choose the values we want to plot. When t is 0, this is 2. When t is 0, and this is x, that's y. I keep saying it as if you guys don't know the x and y axis by now, but it's good to always label your axis. It makes people know that you know what you're doing. All right. So when t is 0, we have the point. Let me go with purple. We have the point t is 0, x is 2, y is 0. When t is 1/2 or 1/4, x is root 2 over 2. Or x is root 2. Root 2 is like 1 point. What is root 2? All right. Square root of 2. Let's see. Square root of 2 should be about 1.4 something. I should have this memorized, but I'm not good at memorizing stuff. So, yes, 1.41. So, we're going to go here. This is 1. So, 1.41 and 1.41. So, around, this is 1 here. Oh, shoot, for the x-axis. So 1.41 there, 1.41 here. So we have that. All right. And then when x is 1/2, you have y is 0. y is 2 and x is 0. Yes. And then when x is 3/4 or t is 3/4, you have the same kind of thing. You have negative root 2 and positive root 2. No, let's do this. Do that. Okay. And then when x is 1, when t is 1, you now have x is negative 2 and y is 0. So that. So let's join it. See the direction we're going. Oh no. Come on, come on. Yes, I did it. We did it. We did it. All right. So this is our direction. We're going in a counterclockwise direction, right? And you can put further labels. This is when t is 0. Oh, shoot. This is when t... No, come on. T is 0 here. And t is 1/4. And t is 1/2, etc. T is 3/4. And t is 1. Okay. So that's our graph. It's a semicircle. All right. The second question now is the question of eliminating the parameter. Want to eliminate the parameter t. Okay. Eliminate the parameter t. So, if you look at this closely, you have a semicircle. So you want to think of a circle. And the equation of a circle is x squared plus y squared is equal to r squared. All right. So let's see what happens here. If we go ahead and say, oh, let's start with x squared plus y squared. What do we know about that? That's going to be 2 cosine pi t squared plus 2 sine pi t squared. And this is going to be 4 cosine squared pi t plus 4 sine squared pi t. If you factor out a 4, you're left with cosine squared pi t plus sine squared pi t. And this is equal to 1. This is 1. So this is just 4. So we end up with, the equation we end up with is x squared. Oh, well, let's write in blue. The equation we end up with is x squared plus y squared is equal to 4. So this is the equation of a circle. Is a circle of radius 2. All right. But you can describe it a little bit more. X goes from, you can say x goes from negative 2 to 2, and y goes from 0 to 2. Okay. All right. So the question would be now, how would the parameter change? How would the parametric equation change if it were a circle? So we see from 0 to 1, we got a semicircle. So maybe if we went from 0 to 2, we end up with a circle. Not maybe, actually, if we went from 0 to 2, we're going to end up with a circle. All right? Okay. So I'm going to write a few notes. In general, if we have, let's talk a little bit more about the circle. The parametric equation of a circle can be generalized as x is equal to a plus r cosine kt, and y equals b plus r sine kt, where AB is the center and R is the radius. And R is the radius. Okay? Now, if the parameter K is greater than 0, the direction is the clockwise direction. If the parameter K is greater than 0, the direction is the counterclockwise direction. Sorry. Clockwise. And if this parameter, if K is less than 0, then it's clockwise. Okay. So let's compare this to what we had upstairs over here. Style, I'm going to make it that, and make it this. All right, so this is the general equation. So let's compare it to what we have. How about bring it here? Compare it to this. All right. You see that our A here is 0. Our B also is 0. The R is 2. This is 2. 2. The K is pi. K is pi. Okay. So this is a circle centered at 0. But it's a semicircle because the parametric curve just went from 0 to 1. So it all depends on how much you want how much of a circle you want depends on the range of the parameter. Okay. If you had gone from 0 to 1/2, you get a quarter circle. All right. Okay. So if we had, say, we had gone ahead and put, say, we have 3 plus 2 pi cosine pi 2 cosine pi theta and 4 plus 2 sine pi theta, then that means that our circle will be centered at 3, 4. All right. Hope you get that. Okay. I'm going to erase this. Erase. Okay. Ooh. All right. So we're going to stop here, and I will continue this video in this section in the next video. All right.